हेलो एवरीवन। आज हम देखेंगे जीडीएनटी का सेशन नंबर 4 में हम डेटम्स मॉडिफायर्स एंड सिंबल्स को देखेंगे। डेटम्स डेटम्स से बनता है 3 पॉइंट से। पॉइंट्स, एक्सेस और प्लेन, तीन चीजें मिला के हम डेटम को क्रिएट करते हैं। These elements exist within a framework of three mutually perpendicular intersecting planes known as datum reference frame. The datum reference frame is a virtual reference frame that does not exist on the part actually. Therefore, it is necessary to establish a method of simulating the theoretical reference frame from the actual features of the part. Next point is simulation method. Simulation method The simulation is accomplished by a positioning specifically identified feature in contact with appropriate datum simulators in a, in a started order of procedure to restrict motion of the datum reference frame. These specially identified features are called as datum features. इन डेटम सिमुलेटर्स हम स्क्रीन पे देख सकते हैं। स्केच में डेटम एक्सिस x, y, z are available and three datum planes are available: x, y, x, z, and z, y. Next point is datum feature. Datum feature consider a surface plate having a real feature of adequately prices from contracting the datum features. This real surface is called as simulated datum features. Now consider a part. A real feature of a part, in this case a surface, which is used to establish the location of a datum is called as datum feature. As datum features are subjected to manufacturing errors and variations, it may be necessary, where appropriate, to specify tolerances of form to them. Next point है datum targets. Datum targets are specific portions of a surface, line, or point that may be used for datum referencing. Sometimes, due to the configuration of a part, its function in assembly, or its rough or wrapped surface, it becomes desirable to use only a portion of the surfaces as a datum. The portion may be designated as a point or points, a line or lines, or an area or areas. The areas may be defined as any shape that is appropriate. Datum target symbol point. Lines and areas on datum features are designated on the drawing by means of a datum target symbol. The datum target symbol consists of a circle cut into half. The top tier contains the target area size that can be placed either internally or externally as shown. The lower tier contains a datum identifying letter with a target number. GD&T symbols and modifiers. GD&T को सिंबल्स और उसके मॉडिफायर्स की हेल्प से हम एक्सप्लेन करते हैं। इन सिंबल्स और मॉडिफायर्स को हम मल्टीपल टाइप्स में डिवाइड करते हैं। टाइप्स ऑफ फीचर में अगर हम इंडिविजुअल नो डेटम रेफरेंस देखते हैं तो टाइप ऑफ टॉलरेंसेस इंडिविजुअल के फॉर्म है एंड फॉर्म हैव many characteristics. Next types of features is individual or related features. In this individual or related feature, we have a profile, line profile and surface profile. Next are related features. Datum reference required have type of tolerances, orientations, runout, and locations, and they have also characteristics and symbol. In detail, we see the symbols and their characteristics. Five types of geometric characteristics symbol. First is profile tolerances. Profile of a line. A uniform two-dimensional zone limited by two parallel zone lines extending along the length of a feature. The amount of deviation that is allowed for a surface to float within a certain dimensional range while maintaining the shape or form of each line elements that makes up that surface. The profile of line shows the symbols of profile of line and the uh, width tolerances. Next is profile of a surface. Uniform three-dimensional zone contained between two envelope surfaces separated by the tolerances zone across the entire length of the surface. स्क्रीन पे हम देख सकते हैं कि प्रोफाइल ऑफ अ सरफेस का सिंबल विथ टॉलरेंस ओरिएंटेशंस टॉलरेंसेस angularity the distance between two parallel lines or plane indicate at a specific basic angle in which the surface's axis or central plane of the feature must lie. It requires that all points on a specified feature must form an angle with a datum. Sketches shows screen sketches shows the angularity symbol. Perpendicularity. The condition of a surface, axis, median plane, or line which is exactly at 90 degrees with respect to a datum plane or axis. It requires that all points on a specified feature must be perpendicular with the datum. हम स्क्रीन पे परपेंडिकुलरिटी का सिंबल देख सकते हैं. Parallelism. The condition of a surface or axis which is equidistant at all points from a datum of surface of reference. All points on surfaces are to be parallel to given datum within a specified tolerances. The figure shows the parallelism symbols. Locational tolerances. Location tolerances have characteristics of true position. A zone within which the center axis or center plane of a feature of size is permitted to vary from its true theoretical exact position. A position tolerance generates a tolerance zone that confines the center plane or axis of a feature of size. It is also capable of conforming a surface or surfaces within or outside of a boundary known as visual condition. Concent- Concentricity. Cylindrical tolerance zone whose axis coincides with the datum axis and within which all cross-sectional axes of the feature being controlled must lie. Conservability is very expensive and time-consuming to measure. Concentricity is a geometric control of the median points of all dimensional opposed element of a figure of a revolution. Symmetry. Symmetry is that condition where the median point of all opposite or correspondingly located element of two or more feature surfaces are are congruent with the axis or center plane of datum feature. Fourth point is runout tolerances. Runout tolerances have characteristics of circular runout. A composite tolerance is used to control the relationship of one or more feature of a part to a datum axis during a full 360-degree rotation about the datum axis. Total runout. All surfaces element across the entire surface of the part must be within the runout tolerances. Form tolerances. Flatness. The two-dimensional tolerances zone defined by two parallel planes within which the entire surface must lie. Basically, all the surface elements are constrained to lie within two parallel planes separated by the tolerance area. Straightness. A condition where an element of a surface or an axis is a straight line. One of the surface elements is constrained to lie within two parallel surface planes separated by the tolerances. This means that if any line across the surfaces is within two parallel lines, the part is acceptable. Circularity. A condition on a surface of revelation, cylinder, cone, sphere, where all points of the surface intersected by any plane perpendicular to a common axis, cylinder or cone, or passing through a common center, sphere are equidistant from the axis of the center. All of the points on a cylindrical surface are constrained to lie within two circles. It is a 2D surface from control. Cylindricity. A condition on a surface of revelation in which all points of the surface are equidistant from the common axis. It is an extension to circularity that specifies the turns along the cylinder. It is a 3D from control which controls roundness, circularity, straightness, and taper. Cylindricity shows the symbol on the screen. Thank you so much.